Okay, so for this one, NoSQL. I think we already discussed this in the very introduction class. Okay, the data is considered very important, and we are in the class that is related to data modeling because it helps us to manage, to collect the data first before you can make use of that data for further steps, such as finding insights into your own data, right? Analyzing the data, bringing certain values from your data. Before you can do anything, you need good data collection, good data model, and the way to manage your data. Okay. And when you are talking about, it is just to recap that the reason we need, okay, the reason we need good data modeling, good technology techniques for data management, because we want to make sure that we choose proper models. Okay, not every, remember when we talk about possible types of data, whether they are structured data, semi-structured data, or unstructured data, and very many characteristics about data. There are a number of suitable models and techniques that could be suitable for different types of data. So we want to make sure that any techniques, technologies you choose, they can address the performance issue. Perhaps they can address the cost issue. Okay. Cost doesn't mean that how much you pay to buy the data technology, the commercial software, but it may also include when you have adopt good technology, it reduces manpower, reduce the time that you need to work on the data, right? Because technology makes your data management easier. You can get work done in a more efficient way and so on. So if it can reduce data redundancy, reduce the storage that you have to buy, right? Reduce computing cost, then it also reduces the entire cost. And in terms of course, efficiency issue, in terms of quality issue, and so on. Okay. So that is why we have to learn a number of, different kinds of data models so that you can choose the right models for your data. And these are those very many models possible. Okay. And I think we already see some of the models in the from the very introduction, right? And we have been learning together in several weeks the relational database technology, in which is very successful, very important, but it's already 50 years old. Okay. Okay, if you can connect successfully, don't forget, give me your heart. I hope you can see the code, right? 82, 18, 98, and 03. So this kind of fun quiz is about relational model versus NoSQL model. Okay, last time you got the first rank, I still remember. It's a red. Now you are here, right? Last time you got the first rank from the quiz. Now you are on site. Let's see. Okay, 27. We have the question mark. 29, 29. Okay, any more? In 2 minutes, we will move. Now 30 students only. Okay. All right, I think we should move now. Okay, are you ready? Don't forget that the faster, the higher score, I mean the correct answer, and then also the faster. But the very first thing is not yet about the quiz. The very first thing, of course, is it the quiz? Okay. What do you think it would be characteristics, benefits, and limitations of relational database? So anything you type could be about characteristics, benefits, and limitation. What's this? You already learned a lot about relational model, right? Relational database. What is this? Harvest. Have schema. Okay, sorry. It has schema. So it is schema full. Okay, if we want to use the term related to schema stuff, so we consider it to be schema full. Someone said it is easy. Someone said it is complex. So that is very confusing now, whether it's easy or complex now. Easy to manage. It has value, keeps data in order, simple of the model, redundancy, accuracy, linked data. Is it really about all about relational database? Consistency. Okay. Okay, I need to say something while you are answering and keeping some inputs. The very first thing, what I do agree with what you post. Okay. Yes, to some extent, relational model is easy. If it is complicated, it's no way that it will survive 50 years of successful in the technology. It's considered to be one of the easy to understand model because of the tabular structure, right? You already mentioned its main structure is based on tables with rows and columns. Don't you think it's easy for people to understand? Very easy. And the principles of keys, principles of foreign keys, connecting or linking data of different tables, they are also not so difficult. Okay. And another thing is, what else? Weird syntax. Okay. Maybe this is from those who are new to SQL, perhaps. If you have been working with SQL and relational model long enough, you will find that one of the good things is that it has standard query language, in which is one of the advantage. You learn the standard language, the structured query language SQL, and you can use in very many products if they are all relational model. Okay. Okay, I think these are more or less what I should say. Okay, we have joy, it has security, redundancy that I see before. I would say that relational model is very much against data redundancy. So if you have a lot of data redundancy in your relational model, your design is considered not to be a very good one. But nowadays we accept more of the redundancy in other models. But still with relational model, redundancy is a main issue that people who love and think relational model is a beautiful model, they hate redundancy. Okay. Anyway, let's move next. How about important characteristic of big data? I think we now are in the big data era, right? So let's warm up a little bit. What do you think would be big data characteristics? Okay, very quick. Volume, velocity, variety. Massive. Okay, value, complexity, unstructured, hard to manage. Okay, very good. All are important characteristics, of course. Okay, I think in many courses and also at work, right? We learn a lot about the era of big data, and that is why you propose here mostly the 3V, 4V, 5V, 6V. There are quite many definitions, but originally it was about 3V, the very original definition. But of course, people add more and more and more. Okay, that 3V are not enough. There are another V and V and V. Okay, so thank you. Actually, the original 3V, okay, start from volume, meaning that the size of the data is big, as from the name. The second V is velocity, right? The speed of the increment, the increasing of the data coming is very high. And data is very variety. Either it is in structured format, non-structured format, unstructured format, semi-structured format, and in any types, any kind. So these are the key characteristics of big data. Okay. And any few words you think they are related to the concept of NoSQL according to your knowledge, understanding? Please share with me. Okay. MongoDB, key value, flexibility, document, dynamic, analytics, no tables, JSON. Okay, very good. Interesting. Handle, volume, lots of volume. No schema, schema free. Cannot predict it. Apache, okay. Document. Okay, I think this tell me that many of you knows about NoSQL somehow. In some class, there were a typo. Instead of typing MongoDB, there was one sharing say MangoDB, and I really feel hungry that time. It's close to the lunch time or eating time. When I see MangoDB, yes, I feel hungry now. Okay, all right, let's move next. I think the next is about, just some concepts to learn together. When we talk about NoSQL, the thing is, it's non-relational. That is why it is called NoSQL, because SQL or relational model has been there, as I said, 50 years. So it has been the most dominant database technology, data technology used everywhere. Okay, and that is why there are some kind of new idea saying that, hey, there should be some other models and technology that could be better than relational. Actually, SQL is not the name of the data model, right? SQL is just the language, query language. But since SQL is the query language for relational model, that every relational model products use SQL, then they just model it or name it as SQL model. And they want to say that, hey, we want something non-relational and we call it NoSQL. Just to say that we want something that is different from relational model. So key important characteristics of NoSQL database that has been arise is that they want to propose some new technology that can handle situation or data characteristics when they are unstructured data, semi-structured data. SQL is very suitable. I mean, relational technology is very suitable for structured data. But nowadays with the big data era, not every kind of data is structured, right? We have seen a lot more about semi-structured and unstructured. So we want different technologies to handle semi-structured and non-unstructured. That is why there are calls, there have been calls for new technologies, non-SQL, non-relational, no schema, okay? And maybe it may not necessarily following ACID principle for the transaction, okay? And actually open source is one of the not key characteristics, but most of the NoSQL data store and technology from the very beginning, they started by being open source solution. So they are kind of considered to be one common characteristic somehow, but not necessary. Scalability is also one issue that NoSQL wants to address because of the big data, as I said. And the last point, NoSQL data models do not follow any standard query language. So if you now move to the NoSQL world, you may need to learn different query language based on different products or tools. This tool will use that language, another tool use another language, and so on and so on. There's no like one language and learn one language and rule them all, nothing like that, okay? But anyway, that is common characteristics somehow. And I think it is now the quiz time, okay? Are you ready? Then you get your avatar, I think. Let's move to the avatar. Okay, how many do we have now? 32? 34? Okay. Who are who? I think you see yourself. Okay, answer fast and get more points. I give quite a lot of time. Okay. Which one is not a reason that NoSQL has become popular? Okay, time's up. So not a reason, okay? So every other thing else must be a reason. So NoSQL has become popular because of better scalability, meaning that it can handle larger volume of data. It is faster to access data, faster than relational database system. Okay, most of the case, yes, NoSQL are faster in depending on types of data, and easily to store data on multiple servers. Yes. And the one that is not a reason is improve ability to keep data consistent. No, this is not the main issue that NoSQL wants to solve. NoSQL wants to solve scalability issue, accessibility issue of the data, and also scaling in terms of having multiple servers. Okay, so these three are main reasons, not the pink one. Okay, what's next? Next question. Okay, ready? The leaderboard will be at the very end, I think. When is it best to use NoSQL? Okay, most of you got it for this time. The reason NoSQL has been developed is to handle large volume of data. So that is one of the main reasons. For the other reasons, they are not the strong point of NoSQL. Okay, NoSQL are not trying to address confidentiality, integrity of the data. Okay. The other points, they are just kind of, yeah, not so much about NoSQL. So the next one. Consider this statement. Is it true or false? Okay. Oh, many of you think this is true. Relational database are being phased out means people don't want to use it anymore, right? Because they want to switch to NoSQL. I am saying it is false because actually relational database is still one of the dominant relational database technology. And actually the key idea is that different technologies are suitable for different types of data. So it should not be that there will be only one technology surviving. Different technologies will be co-existing, okay? But then we need to use and choose the right technology for our data. That for these types of data, you should use relational model. For these types of data and requirements, you should use document model. For other types of requirements and data, you may use key value or something, okay? So if they are phased out, we won't spend 6 weeks learning relational model. Okay, next please. Okay, these are the explanation. Okay. Okay, so I can read it one more time what is said here. Although NoSQL offers new capabilities and can solve certain problems better than traditional ones, right? But users and consultants, we agree that relational models continue to be crucial, okay? And it can fill crucial data needs and likely to retain their leading role in transaction processing and business intelligence application in foreseeable future. I think we, sorry, I can Oops. Okay. Maybe we can look at this again. I think from the very first class, I have shown you here already, right? If we talk about engines rank, database engines ranking, the very topmost one, top 10, 8, 6, 7, 7 out of 10 are still relational models, technology, are still engines for relational models. Okay, but of course, other types of technology are gaining more importance in today's world to handle more of the semi-structured data. Mostly the other types, what are they? MongoDB, document model, and of course, support multi-model as well. Redis, key value. But anyway, you can see as well that most of the technology, they tend to make themselves spanning more areas. They are not very kind of single model. Like Oracle MySQL, it is said here that it's kind of multi-model as well. Oops, cannot click here, sorry. What does it mean? Multi-model. Now, oops. Engines tend to cover, or expand their capabilities to be able to handle different data model technology too, such as they tend to become like not only relational, but document and so on, but still they have their primary focus. Okay. All right, so let's move back to our Menti. So what's next? Where is the control? Okay, go. Let's go next slide. Okay, 3 more questions. Which one is true? Okay, only the true statement. Okay. Sorry, I think for those who answered the first one, because I said that there is no SQL support, it's not mandatory that they must use standard query language, but there is also no harm, right? If some system, they want to adopt SQL, that's fine. So some of the NoSQL may have SQL-like language support, but it's not any of the rule that force them to do that. So this is not true that they don't support at all. It's not true. They cannot be used in conjunction with RDB. This is also not true. You can use multi-technology together in your system, in your application. And they are the most commonly used database today. No, we just see the DB ranking, right? And we found that the most commonly used are still RDB or relational database. So the one that is true is that NoSQL has been developed for the main purpose of managing large data sets and distributed over multiple servers. Okay. Okay, next question, please. Okay, this is the explanation. Consider this statement, please. So you have to read. Okay, finish. The question is, that statement is true or false? Do you agree with it or not? Okay, yes, we do agree. We need to consider the requirements, right? While new database technologies have a lot to offer, right? The new technology is not always the best choice. You need to always making the decision based on your needs, your requirements, of course, your organization, your business model, and many more, right? Okay, so I think the last question remains. Let's go. Which one is not NoSQL database? I think we have seen these names of NoSQL database many times, right? Which one is not? Okay, the question was which one is not NoSQL, right? So key value is one type of NoSQL for sure. We will learn. Columnar or Y column is another type. Graph is another type of NoSQL. Document is also another type. The one which is not is we don't have a NoSQL model which is called tree, but we just have key value, columnar, graph, and document. And we will learn all of these four. Okay. So sometimes I think I know the question text is a little bit confusing when we say which one is true, which one is not true, and so on. Okay. All right. Anyway, this is just for fun. And I think we finished about learning anything related to NoSQL today. Wow. Nitin, ready? Where are you?
I'm an online professor.
Okay, you are online. But are you in Thailand already?
Yeah, yes, professor.
Okay. Then you should consider coming to class.
Yeah, sure, professor.
Okay, and others, congratulations to everyone. Actually, this is just for fun, and I know that I have made a lot of questions to confuse you. Okay, so congratulations to everyone, and thank you for this quiz fun time together. Okay, so my plan for today, the remaining is still about this slide. Okay, but we can go quickly now because many of the things I have already explained. Any things you want to ask related to the quiz or not? Anyone have questions related to the quiz? If not, then I continue. Okay. Okay, so I bring this diagram back so that you can now see clearer that the evolution of data models for NoSQL is here, the very bottom of the chart, in which it arises due to the response for big data, the need for technologies to handle big data issues. Okay? Address big data problem, less semantics in data model, and based on schema-less concept, key value concept, and best suited to handle data when the case of large sparse data store. Okay, and in this slide, this is somehow compare a little bit in terms of what has evolved. Okay, from relational model of the very structured data to something which is more towards unstructured and semi-structured data that we are facing nowadays. From size of data, which is much smaller, to the scale of data, which is larger in volume. From data in which, of course, even it is relational model, right? In which we talk a lot about data having relations among each other, but the connection or relationships are less in the past than what we have today. And in terms of data design and development approach, in the past, it was based on waterfall approach, in which nowadays it's much more on the agile approach, and many more, scaling up and scaling out, so on. Okay, and these are the 4 types of data models, NoSQL data models that we will learn. Okay, we already mentioned the names: key value, columnar or wide column, document, also, and graph. This slide, this picture show the DBMS quadrant in terms of data complexity, how much the model can handle complexity of the data, versus the relationship complexity within or among data themselves, how much of the relationship they have with each other, and how can the DBMS could handle them. So you could see from this quadrant that different technologies definitely are appropriate for different characteristics of the data. When your data is very less complex in terms of the data complexity, in terms of the relationship among the data themselves, key value could be a good solution. I'm talking about also when you are handling large volume. Okay, if your data is small, any technology will be fine. Maybe you don't need to worry much, right? Even your data is small, you can just write. I mean, small in the case that you can even manually manage the data, right? In certain situation. But then with columnar technology, columnar model, with document model, okay, also with relational model and graph model. Each of them are more suitable with different situations and scenarios. So that is why the most important point that has been mentioned also in the quiz, you also need to evaluate or make your consideration. Evaluate and consider to use or to adopt any data model based on what? Based on the needs and the requirements, right? In which it's concerning data characteristics. It may concern the relationship you have among the data, right? That is about the data characteristics anyway. The complexity of the data, the relationships data have together with others, the structure, unstructured, semi-structured character of the data, right? These are those things about data characteristics. Also about the volume of your data, how big, how small it is, right? Different technology may be good at different scale. Scalability issue of your data, cost, performance, efficiency, and many more, right? Those are the criteria you may need to consider. Not just like, hey, we have to use this technology or not. Okay, so that is the conclusion point. One size fits all database may not exist. You cannot just say that this is the number one database technology that can be used for any kind of problem. So what we will consider is that there is a term which is called polyglot persistent. It means that we need to choose the right tool for the right use case. And we may need to combine or integrate multiple solutions to solve your problem. So it may not be that you can use only relational model, nothing else. No. In order to solve maybe your problem, you may need to combine, use relational model for this part of the problem, use key value for another part of the application, and so on. It can be the case as well. It really depends. So that is this point that has been mentioned here. Different kinds of data could be best dealt with by different data technologies. Okay. This is an example of what polyglot persistence concept would mean. It could mean, in this example, I took from one textbook, that is, suppose, okay, this is not also the reference that every e-commerce platform must follow this, right? But this is one example of what polyglot persistent could mean. It could mean that for an e-commerce platform, if you want to handle shopping carts and session data, in which data is very simple, but of course, updating of the data and retrieving of the data must be fast, and volume could be a lot as well. So we want some technology that is simple but fast. So key value could be one answer for handling this situation. Also, something related to inventory and products. It could be based on relational model technology, in which it is very good as well. Okay, the company, long history company may have already been implementing their inventory system using relational model, in which it has been working very well. And in terms of orders, completed orders to archive, document store could be one solution to be used as well. And in terms of handling customer relationship management and customer social graph technology could be adopted. So this example shows that even in one business, it may involve adopting different solutions, technology solutions, and combine them. Okay, and that is called polyglot persistent. So these are some examples that which types of functionalities, application usage are suitable for which kind of data store technology. Okay. And actually nowadays, you can also check as well that many of the cloud services, for example, we may use cloud service for existing for serving our data needs, right? So most of the cloud provider, they do support multiple data technologies too. This one I took from Amazon, okay, AWS service, that it may support either relational, key value, document, graph, in memory, so on, by using many of the various products they provide. And other cloud providers do similar things, but they do have their own products to serve too. So this is to summarize. We choose and design database system, okay, to match the use case. And if you are a database designer, developer, you also need to be very flexible, right? To adapt, to design, and to recommend any technology suitable. Not to say that I am relational database administrator for the end of the life. No way, right? There are needs that you may need to learn and use other technologies and be able to use variety of technologies. And as I always mention, the reason we need to have very good data infrastructure because data is just a starting point. We need data for many things, right? To support us. And we need to make sure that if data is the starting point for all the value for your business, you must make sure that you have quality data maintained. Not just that you have data, right? But you need to have quality data. And characteristics of quality data, important ones are in this dimension. You have data, but if they're not accurate, there's no point. You have data, but if it is not complete, up to what you may need, is also no point. If it is not reliable, if it is not relevant to what you need to your business, it's also not a point. And the last one, but also not least, is the timeliness. You must have it in the time, in good time that you need it. Later data, if it is too late, doesn't mean anything. For example, if you're talking about cryptocurrency, stock exchange, forex, one day is too long. Maybe 2 minutes later of the data, sometimes you can lose a lot of money, right? If you know something that is too late, even you have the data, but the data comes at a very late stage, it's no point to you as well. Okay, that is the timeliness. And I think you know about this already. Okay, we need the data for the analytics pipeline. So you need to start having data, as I said, it's just a starting point. So what else I should say? SQL, NoSQL, they can coexist. Okay. And we talk about them later, how they are different. And they can be used for different purposes. As I already mentioned, key value can be good for something like session management, shopping cart, document may be good for certain kind of document-based data, columnar for some other, and so on. If it is for graph, it is definitely very useful for connected data with a lot of connection among each other. Okay, and I think these are simple stuff that we already mentioned. Relational database has in the past, and the reason for having development of NoSQL are to handle scalability issues, are to handle the requirements that we may need. We may not need only schema full database, but we often need sometimes schema-less database as well. We don't want very strict schema. So you need to try to relate all these issues with the projects you're working as well, whether do you think they are true with your case, your project or not. Okay, not every statement is true for every situation. Okay. And okay, you can read this, okay, a little bit. Some humor. So when I say there's some humor, you should at least pretend to laugh, okay? Okay, sorry. And another humor. Okay, thank you. So we are not a NoSQL lab or classroom because we do have a lot of tables here. So next time when we are fully in the NoSQL mode, right? Then the tables should be removed from this room. Again, you need to laugh, okay? Sorry. Okay, I think many of these slides we already mentioned in the quiz. Okay, so I will not repeat something that already been mentioned. Okay, just some history that I already briefly talked about, but maybe good to remind a little bit. The NoSQL is a term that is used to describe high performance, that is the key thing, and non-relational database. When it is said to be non-relational, it means that the relational model, as I already mentioned, is based on the principle of tables with keys, with columns and rows and key and foreign key, right? And also the transaction processing. The very strict transaction property is called the ACID transaction properties that many of the relational system can enforce, but of course it is up to the database implementer whether you enforce the ACID transaction properties or not. Okay. And another thing with SQL, this is about not SQL. I should say relational. This is the main principle of relational model, right? The very important thing about relational model is to be schema full. So the concept of schema is very strict in relational model, in which NoSQL wants to relax that kind of concept. And also the concept of what is called data consistency is also very strong in relational model, but again, wants to be relaxed in NoSQL technology. The reason for relaxing some of these is sometimes you may need to trade off. You cannot have everything so strong, right? When you want to achieve something else that is in terms of scalability of the performance, in terms of the high volume of the data, when they are a lot of data. And if you really have to enforce all the schema restriction, enforce all the consistency rules and so on, handling large volume of data would become impossible in terms of fast response, efficiency, and so on, right? So that is the reason why there are certain kind of relaxation in terms of these strong rules. Okay. So these are examples. For example, if you have some data which do not follow a schema that you define, what will happen? If it is relational model, you need to revise the schema. If, for example, your table of student table, we have student table saying that we have ID, we have name, we have country, we have email, we have many more. If your schema say that all of them cannot be now, this is also the schema that restricts the data input and maybe want to make sure quality data, right? You don't want to enter something in which you have not complete data yet. But then it prevents you to record such a data if you don't have all of this information available. But then if somehow you want to also record something like, what else I should need? Facebook ID. Oh no, Instagram maybe, IG. If the existing schema, we don't have this column of recording the account of IG, then what do you have to do? You need to alter the schema, right? Add new column, right? Yes. And that means every column suppose that in this student table, we have 100 still, okay, 100K students is not big deal. But when you add a new column IG, what will happen to the existing row? This become what? Now. And again, relational database people, we don't like now value if possible. We want to avoid having now value and we say that it's not good, right? But anyway, it is possible. Technology-wise, it's possible. But still, you need to add all this now value and maybe later on find out to complete the data later. But again, many records will be filled up with now. That is also not a good design. Also having very many problems when you want to change the schema in relational database. So that is one of the reasons that sometimes very fixed schema can lead to some problem, especially in the situation where your data is kind of for well-structured data. RDB is a good choice. For semi-structured data, and when the data is so flexible, RDB and relational model is not a good technology to support that case. And you will be able to see it in some practice as well. And also composite attributes are not allowed. Multi-value attributes are not allowed. Structure inside your attributes also not allowed. Okay. So there are quite a number of Drawbacks: if your data do not have fixed, do not have rigid schema, okay, then it's better to use schema-less database. When your data do not have by nature fixed schema rule. And when your data seem to have a lot of now in many of the data value and strong data typing. If it is not there for your data, then it is more appropriate to use some of the NoSQL technology too. And that is the schema-less database in many cases. Okay, this graph just show that in the late 20, okay, after 2000, there are more of the same, there are increasing volume of data, which is in terms of semi-structured data and unstructured data, especially when we talk about data in the internet, in the web applications. Most of the data you have are semi-structured and unstructured. So relational models are still the good choice when your data is very well structured. Okay, so let's talk about these 4 types of NoSQL, and then we will be done. In brief, the first one that I will go into the detail is key value. The principal concept of key value is that it's the simplest model among all the 4 types of NoSQL. The model of key value is based on just the concept of key and then value, nothing else. We need to define something to be a key, and then anything that is related to that key is the value, is the associated value. So in this example, sorry, it's very Thai oriented. They are kind of, I use this one for some example in some other class. They are Thai actors, okay? So this one is a person, a Thai actor named Nadet. So the key is just his name. And the value would be anything related to Nadet is what is associated with the key. So you can, conceptually, you can associate any key K1 with any value V1. And the value can have any structure. No fixed rule for the value. It can be just any string. It can also have some textual structure, such as have substructure of key and value inside, or have something else. Or it can be an object, such as a photo, a video, or anything. So the concept of key value is that as long as you have one key and one value, that's it. The key allows you to retrieve the associated value. So there could be another key, such as Yaya, and this associate to anything about that key, such as it could have some structure of another attribute and value, such as name is Yaya. She is studying program IM. She has her Facebook. She has her video, and so on. This can be any structure. The main characteristics, as I can summarize, is that no schema at all. As long as I said, key 1 to value 1. Key 2 allows you to access value 2. Key 3, value 3, and so on. And the value, as I said, can be any object type, can be a simple string, a simple number, an integer, a decimal, can be JSON document, can be binary object, anything else, and anything. The query or the operation that you can do with key value also are very limited or simple. That is, you can put the value to the key. You can say that this value associated with this key. You can get means you retrieve the value associated with the given key. You can delete the value or the key from the data store. That's it. These are main operations. Of course, different stores may have some different types of operations offered, but the main ones are like this. Okay. Benefits and limitations. When you have something very simple, the main benefit is that can be very fast because there's no need to worry about any structure, any schema, any constraint, nothing. As long as you give the key, you can get the value. I give you this key, I will obtain this value. Okay. And virtually no restriction on the type of data to store. You can store anything, such as it can be a key to a video, could be a very big a file associated with that key and return to the user, for example. Okay. So any types of binary data, multimedia binary data, such as photo, audio, video can be used in this key value scenario too. Or it can be, the value can be HTML file, HTML text for web server to archive all the text file, all the HTML archive and so on. Okay. But the restrictions may be there. So these are the theory for key value store. The real implementation may be different from one implementation of key value to another, but mostly they are like this. Could be the case of the size, such as associated value shall not be larger than this size or something like that. Limitation. It does not care about the associated value, the system, the store. So you may not be able to search within the value. You just need to retrieve the value from the key. What is inside, of course, you write a program to handle it. Once you get the value associated, you can do anything you want. But of course, it's internal to your application program. Okay. But the data store just retrieve the value for the given key. That's the main thing. And you cannot do things similar to, for example, relational model, such as for example, in relational model, you can say that select star from student where name like, suppose I want anyone whose name start with P. I can say something like this, right? This is to search within the value. Of course, you cannot do this for the key value store. You cannot do the update, such as update. Suppose I want to update the student grade, saying that we give this grade for every student or we update something, then you cannot update only part of the value. You need to just replace the whole value with the new one. Okay, that is also the another limitation of key value, because it just say that your key one associate with value one. If inside your value one, it is some structure that you want to partially update, the thing is just you need to delete value one from key one and supply key one with a new value two. And inside new value two, of course, you do some partial update. That is fine. But you cannot just like update only certain part of the value. Okay. So use case is that it is best suited when your applications require the access through the key in most of the case. You cannot do any access through the value, as I said. By students whose GPA is greater than 3.0, then this is not possible, because that means it needs to access the value, right, inside and then search whether the value satisfies the condition or not. Then in that case, of course, it means that every key value must be retrieved and checked for the condition, in which this is not a good use case for key value. Okay. And then the second model that we go and consider together quickly is document model. It's considered to be a specialized key value because it is the case that it is the key that is the document ID associated with the whole associated document at the value. So it's considered to be the key and the value in a way that the value is a special structure following document structure. And document structure in most cases of document store nowadays, they are JSON, because they are very easy, right, to get a lot of object structure in many of the programming technology and so on. Okay, so in the past, when we talk about document, it can be XML document as well. Actually XML and JSON, they can be transformed from one to another anyway. Okay, but I would say XML is now not used a lot in terms of storing, in terms of use in the document store, mostly just JSON. Okay, and important CRUD operations in documents, they are just the CRUD, yeah, creation or insert new document, retrieve or query existing document based on some condition, update or edit the associated document, delete or remove the document from the store. So I think CRUD operation, they are main operation for most of the NoSQL anyway, except that for key value, the CRUD operation are very limited. Okay, the next one is columnar or column family. Why column? There are quite a number of names. Again, column family also enhance key value. But again, for the value, if it is document, the key is still the same, right? The concept is the same. That is, you have document ID associated with the value structure, which is supposed to be JSON. When it is column family model, the value has certain extra additional structure that allows more of the some of the structure in which we will learn more. Okay, and some key thing is that it's also one of the very beginning model with influenced by Google's big table technology, and the very popular one and most used one nowadays, they are Cassandra, HBase, and so on. We skip a little bit, okay? We will talk just the overview because we have in detail of these of the technologies we discussed anyway. The graph model, I think this is one of the simple model, intuitive model, easy to understand because it follows the structure of connecting the nodes and relationship. So it has structure which is node linked structure. So you have nodes in which nodes can carry information or data. Node can have data. So this can be a node which is representing a person. This can be another node which represents an artwork, for example. This can be another node, of course, another person, and so on. So the node can be just any types of object, and link refer to relationships that those nodes can have with each other. And the links can also have direction. So we call that they are directed links. Okay. So in this case, this kind of data structure forms as a graph. So that is why it is called graph store or graph model. So it is useful when you want to model data that has strong connections and relationships among each other. They are kind of not complex, but there are a lot of relationships among each other. So this node connects with that node with this relationship and so on. Okay. Nothing much here. We will learn in the detail anyway. So I think these are the 4 types of the 4 major types of NoSQL, and they are very different, and they are useful for really different use cases and scenarios. Okay. And if I go back to this slide, where am I? Here. So that is why I think you can now make some make better sense of this quadrant, right? Key value is by no question is the simplest NoSQL model, and it also handles the simplest form of data. Okay. Relational and graph actually are very related to each other because they form as data with attributes such as nodes and also connection of data from one to another. So they are very related somehow as well. And document, key, and column, they are also similar in the way that they enhance from the concept of key and enhance the structure of the value. Instead of being very simple key and value as ordinary key value technology, document expand the value to have certain semi-structure concept in the document itself. Okay. And column also expand the structure of the value to handle additional substructure within the value itself too. Okay. And I think that's all for the plan for today.